Hello students, let's do congruency. Congruent triangles, exercise 21. Exercise 21 is on page number 232. Question 5. In the given figure, prove two things. Question 1, that triangle ACB is congruent to triangle ECD. Second one, AB is equal to ED. So we have this figure and we have to prove these two things. So first, let's write down those 5 axioms or the 5 conditions that we have of congruency. And let's see which of these conditions we can apply to prove that triangle ACB is congruent to triangle ECD. So let's begin by saying this is a question, and in triangle ACB and triangle ECD, okay, ACB and ECD, in these two triangles, AC is equal to CE. Can you see that? AC is equal to CE. How do we know that? Because of these single strokes. So these two lines are equal to each other. Similarly, BC is equal to CD because these two lines have two strokes. So we have this AC is equal to CE and BC is equal to CD, and this is already given to us. Now we have two sides. Now let's look and see if we have a third side, or if we have, now wherever there are two sides, now we have to see that we have an angle in between. So two sides and an angle in between, or three sides. Now here the third side is opposite, so we can't include the third side. It's not equal, they've not told us. So now let's look at an angle. So here angle ACB, that is angle ACB, if you look carefully, if I take this angle ACB here, and angle DCE, which is on this side, can you see that these two are vertically opposite angles? And we know that vertically opposite angles are equal. That's why we've written angle ACB is equal to angle DCE, because they're vertically opposite angles. So what do we have now? We have two sides and an angle. And this, as you can see, is an included angle because it's in between the two sides. Here also it's an included angle because it's in between the two sides. So we can use this second condition, side, angle, side. So here we can prove that triangle ACB is congruent to triangle ECD by the side, angle, side axiom. So now let's go on to the next one. So here we have proved it. Next, line segment AB is equal to line segment ED. AB is equal to ED because this and this are corresponding sides, and corresponding paths of congruent triangles are equal. How did we come to that conclusion? Only because these two triangles are congruent can we say that these two sides, corresponding sides, are equal, because in all congruent triangles, the corresponding sides and the corresponding angles are equal. So it's only because of this. Okay, so once we have proved this, only then can we say that AB is equal to ED. And what is the reason? Corresponding paths of congruent triangles are equal, so we have proved this. Question 6. Prove that triangle ABC is congruent to triangle ADC. So we have ABC. We have to prove that this triangle is congruent to this triangle, that is ADC. That these two triangles are congruent, we have to prove it. So that's a set of axioms, the 5 axioms or the 5 conditions we have, and let's see which one we can apply to prove that these two triangles are congruent. So first question is this: prove that these two are congruent. So in triangle ABC and triangle ADC, can you see that AB is equal to DC? That is, AB is equal to DC. They are corresponding sides and they are equal. Similarly, BC is equal to AD. BC is equal to AD. They are also corresponding sides. They are equal, and this is already given to us. So here we have two sides. Now let's see if we can make use of a third side. The third side is AC. As you can see, this side AC belongs to this triangle as well as to this triangle. That means it is common. So AC is equal to AC, and the reason is it is common to both the triangles. So here we have 1, 2 and 3 sides that are equal. So we can use the first condition which says side, side, side to prove that these two triangles are congruent. So triangle ABC is congruent to triangle ADC, and which is the condition that we've used? Side, side, side axiom. So here we have proved it. Now what is the second question? It says angle B is equal to angle D. So let's write that down. Now where is angle B? Angle B is down here and angle D is up here. Now here we have proved that these two triangles are congruent, isn't it? So if two triangles are congruent, that means the corresponding angles will be equal. So that's why angle B is equal to angle D. And what is the reason? CPCT, the corresponding parts of congruent triangles are equal. Hence we have proved. Question 7. In the given figure, prove that BD is equal to BC. Now, where do we have that? We have BD here and BC here. We have to prove that these two sides are equal to each other. Now, no measurement has been given. So, how do we know that they are equal? So, the first thing we have to do is we have to prove that these two triangles are congruent. If these two triangles are congruent, then we know that the corresponding sides of all congruent triangles will be equal. So only then can we say that these two sides are equal. So the first thing we have to do is prove that these two triangles are congruent, and let's see which of these 5 axioms we can use. So let's begin. So this is what we have to prove. Now in triangle, right triangle ABD and ABC. Now why are we saying right triangle? Because both have 90 degrees and they are right angled triangles. So in these two triangles, what is given to us is AD is equal to AC. This is given to us. AD is equal to AC. This is already given to us. That is one side. Now let's look at another side. These two sides we have to prove are equal. The other side is AB. Can you see that AB belongs to this triangle as well as to this triangle? That means it's common, so they're equal. So AB is equal to AB because it is common. So now we have two sides. We have these two sides that are equal to each other. Third side is what we have to find out. What else have we been given? Can you see that we've been given 90 degrees here? That means we are saying they are told us that angle ABC is 90 and angle ABD is also 90 degrees. So this is also given to us. So now which axiom will we use? We have two sides. Now we have one side and this side, and we have this side that's common, and we also have a 90-degree angle. So whenever you have a 90-degree angle, use the fifth axiom, the fifth condition, which says right angle, hypotenuse, side. So let's look at the right angle. So we have a right angle. Now let's look at the hypotenuse. Now the side that is opposite the right angle is the hypotenuse. Now this is the side, and here this is the side, and they are also equal. Then one more side. So we have the third side, that is AB, that is also equal. That means we can use this condition RHS and say that these two triangles are congruent. So triangle ABD is congruent to triangle ABC by the RHS axiom, or the right angle hypotenuse side axiom. So now that these two triangles are congruent, we can easily say that these two sides, that is BD and BC, are equal because corresponding parts of congruent triangles are equal. So BD is equal to BC because of this condition. So this is how we prove it, and this is proved here. So we finished proving that these two sides are equal. First, we have to prove that these two triangles are congruent, and only then can we say that these two sides are equal. Question 8. In the given figure, angle 1 is equal to angle 2. So we have these two angles equal to each other, and AB is equal to AC. So AB is equal to AC. So we've been told that one pair of corresponding angles are equal and one pair of corresponding sides are equal. Now we have to prove a few things. So first let's write down the conditions. We have these conditions. Now the first thing is we have to prove that angle B is equal to angle C. So that's the first thing we have to prove. Now angle B is here. Let's mark that. So this is angle B here. So we have angle B and we have angle C. Now these are corresponding angles as you can see. Now they will be equal only if these two triangles are congruent. So first we have to prove that these two triangles are congruent. If they are congruent, then angle B will be equal to angle C because they are corresponding angles. So let's look at the two triangles. Triangle ADB, ADB and ADC. So these are the two triangles. Now we are going to use one of these axioms to prove that these two triangles are congruent. So now let's see what is equal here. So here AB is equal to AC. AB is equal to AC and angle 1 is equal to angle 2. This is already given to us. Now look at one more side, the side AD. This side AD belongs to this triangle as well as to this triangle. That means it is common. So AD is equal to AD, that is common. So here what do we have? We have two sides and an angle. Two sides and an included angle. So which of these properties or conditions can we use? Two sides and an angle means this one, isn't it? Side, angle, side. So with that we can say that these two triangles are congruent. So triangle ADB is congruent to triangle ADC because of this axiom side, angle, side. So now that they are congruent, we can say that angle B is equal to angle C because they are corresponding angles and corresponding angles of congruent triangles are equal. So we can say that angle B is equal to angle C, and what is the reason? CBCT. So we have proved it. Now we have to prove the next one. BD is equal to DC. Where is that? BD is equal to DC. So we already have two sides here. This is one pair of corresponding sides and this is common sides. So they are equal. And we have to prove that these two sides are equal. So that is the second one. And as you can see, they are equal. Why are they equal? Because they are corresponding parts of congruent triangles. Here we prove that the two triangles are congruent, isn't it? So if they are congruent, then these two sides will also be equal to each other because they are corresponding sides. So we have a reason. Now the next one we have to show. So here we have proved it. Now next we have to show that AD is perpendicular to BC. Now AD is perpendicular to BC. What are perpendicular lines? Perpendicular lines are straight lines which cut another line at right angles. That means if this line AD is cutting BC at right angles, then we can say that that is perpendicular to BC. So we have to prove that. So here angle ADB, that is angle ADB, is equal to angle ADC because they are corresponding parts of congruent triangles. So here let's mark that. That is ADB is here and ADC is here. That means these two triangles, these two angles here are equal to each other. And how can we say that they are equal? Because they are corresponding parts of these two congruent triangles. So if they are equal, remember there's another property that we can apply here. That is, if we add up ADB and ADC, they will be equal to 180 degrees. How do we know that? They are linear pair. We know that two angles on a straight line are called linear pair and they will be equal to 180. So now we can find out the value of these two angles. So here what do we say? Now angle ADB, let's write it as it is, angle ADB plus, now here we have angle ADC. Now instead of ADC, I'm going to write ADB. Why? Because they are both equal. So I can write this also, isn't it? So let me write angle ADB is equal to 180 degrees. So now we have one angle ADB and one angle ADB, one more. So 1 plus 1 is 2. So that will be 2 angle ADB is equal to 180 degrees. So if we have to find only one angle ADB, then what do we say? We say 180 degrees divided by 2. 180 divided by 2 is 90. So now we know that angle ADB is equal to 90 degrees. That means angle ADB is 90 degrees and angle ADC is also 90 degrees. So we have written that here. So now can you see that this line AD, which has cut BC, has cut it at 90 degrees. So remember, what are perpendicular lines? Any line that cuts another straight line at 90 degrees to it is called a perpendicular line. So here we can say that AD is perpendicular to BC and we have proved it. So we have finished proving all these three statements here. Question 9. In the given figure, prove that two sides are equal. What are the two sides? PQ and RS. We have to show that they are equal, and PS and QR are equal. Now we can show that these sides are equal only if we can prove that these two triangles are congruent. So to prove that these two are congruent, let's use one of these conditions or axioms. So let's begin with the first one. PQ is equal to RS. We have to prove that these two sides are equal. So let's take the two triangles PQR. Where do we have that? PQR, this is the first triangle, and PSR, this is the second triangle. So in this, can you see that PRQ, now which is PRQ? PRQ is this, okay? This angle PRQ, we're talking about the angle PRQ, and RPS, this RPS is here, the one in red. So this angle and this angle are equal, and we also know that equal because of the two curves. So there are two curves here and two curves here. That means these two angles are equal. Similarly, PQR. Now PQR is here. This angle, we are talking about this angle here. This one that's in blue. So now these two are equal and these two angles are equal. So now we're talking about two angles that are equal. Now can you look at this side PR? Now this side PR is common to this triangle as well as to this triangle. That means that they are equal to each other. So PR is equal to PR and this is common. This is given to us and this is common. So now what do we have? We are talking about two angles and a side, two angles and a side. So let's see which condition we can use. So here we have two angles and a side and two angles and a side. Now here side is in the middle. That means we're talking about an included side. Angle, included side, angle. Now here let's look at the two angles. Now we have two angles here and the side is here. If it is an included side, then this should have been this side. This side is in between these two angles, but we don't know about this side, isn't it? And we only know that this side is equal. So it is two angles, but not an included side. It will be angle, angle, side. So which one is that? Angle, angle, side. This fourth condition. So with the help of that, we can say that these two triangles are congruent. Triangle PQR and triangle PSR are congruent because of the angle, angle, side axiom. Now, if these two triangles are congruent, then you can say that PQ is equal to RS. PQ is equal to RS because they are congruent. They are corresponding sides of congruent angles. So PQ is equal to RS and this is the condition CPCT. So here we have proved it. Now the second one we have to prove is that PS is equal to QR. PS is equal to QR, PS is equal to QR and they are equal. Again, because of the same condition, they are corresponding parts of congruent triangles. So unless you prove that the two triangles are congruent, you cannot say that they are equal. But since we have proved it, we can say that these two sides are equal because they are corresponding sides of these two congruent triangles. So we have proved this also. Question 10. In the given figure, prove a few things. First one, we have to prove that these two triangles are congruent. So, to prove that two triangles are congruent, we have to use one of these axioms. So, what are the two triangles? X, Y, Z and X, P, Z. So, that's the first thing. We have to prove that these two triangles are congruent. Now, whenever you see a right angle triangle, remember, so in triangle XYZ and triangle XPZ, so these two triangles, let's see what has been given to us. XY is equal to XP. Can you see? XY is equal to XP. It's already given to us. So that is one side. Now if we take another side XZ, that is equal to XZ. Why? Because it's common. This side is common to this triangle and it's common to this triangle. So they are equal to each other. And we've also been told that angle Y is equal to angle P, and that's equal to 90 degrees, and that is also given to us. So here, whenever you have a right angle, look at the last condition, which has R. R stands for right angle. So both the triangles have a right angle. Now let's look at the hypotenuse. The hypotenuse is the side that is opposite the right angle. So what is opposite angle P? XZ. Here also opposite Y is XZ. And we know that XZ is equal to XZ. So the hypotenuse is also equal. So R is equal, hypotenuse is equal. Now let's look at the other side. The other side, XP is equal to XY. So that is also equal. So now we can say that R, H and S are equal. That means these two triangles are congruent. So here triangle XYZ is congruent to triangle XPZ by the RHS axiom, and hence we have proved it. Now the next thing that we have to prove is that YZ is equal to PZ. YZ is equal to PZ, and that will be equal. Why? Because these two triangles are congruent and these two sides are corresponding sides. And the reason is corresponding parts of congruent triangles are equal. So we have proved that also. Now what else do we have to prove? We have to prove that angle YXZ. Which one is that? YXZ. We're talking about this angle. That is the angle in yellow. We have to prove that it's equal to PXZ. That is the angle in red. Now these two angles, as you can see, are corresponding angles and they belong to congruent triangles. So corresponding parts of congruent triangles will be equal. So we can say that angle YXZ is equal to angle PXZ because of the reason CPCT, and this is proved. So we have proved this also. So children, we'll stop with this question for now. In our next video, we will continue with the remaining questions. Thank you, children.